Good evening, class. Tonight we're going to be talking about those questions I gave you the other night, questions 6 through 10. These were the extra questions um, that we talked about. Now, let's take a look at number 6. Okay, there's a roof with an 85-foot diameter, and this is the one that I asked you to add to the 6th, the book version of the 6th. Okay, so this was an 85 foot diameter round roof. Now, I know I mentioned this in the last video. We don't see too many round roofs. I don't think I've ever seen one. Certainly nothing that I worked on, but makes a good test question. So there's two parts to this question. Now, before I even get going, uh, because this roof drain section is so important, I did the whole thing. Now, if you find a math area, please let me know, because this was not out of a book. All right, I had to do the math myself. So there's an outside chance it could be a mistake. Okay, so if anybody finds a mistake, please let me know. All right, so let's get started. If we have a roof that's 85 feet across, what would the area be of the roof? Okay, it's basically what's the area of a circle? And the book answer is area equals the diameter squared times 0.7854, which is roughly 78.5% of a square. All right, so we take the 85 and square it. If you're following along on if you downloaded that sheet that I think Maureen would have sent you after I go through this, you'll have it before you even view this video. You'll see that it comes out to 7,225 square feet times 0.7854. So if it was a square, it would have been 7,225, but it's a circle, so we multiply it by 0.7854. It comes up to 5,674.5 square feet. All right. Number 7. Now 7 is a continuation of 6. So take the same problem, and we're going to be working with that 5,674, 5,674.5. And the question is, what is the size of the roof drain? It means vertical. Remember, if you don't see anything about the pitch, it's vertical. So what we do is we go into the chart on page 182. Okay, and like I said, I suggest you use that other. I think Maureen sent that to you last class. It's a copy of the page out of the book, page 181, that I actually added the vertical numbers that you need from the next page. All right, so let's see what we got. So we got 5674 vertical. Let's go into the chart on the vertical. 4-inch can only go up to 4600. All right, so the next one is 8600. That's 5-inch. Okay, so the answer for the vertical drain, right? And like again, you can see it there. This is the answer, is 5-inch. It's off the chart. Okay. What's the size of the storm drain? 1/4 inch per foot. All right, this would be the vertical pipe coming down and then going horizontally, the same pipe, 5 inches down. And what is it going across? All right, this one's a little different. This one here, because it's 5,600 at 1/4 inch to the foot, let's look down that column. And you'll find that 5,600 is a little too big for 5-inch pipe. 5-inch only goes up to 4,720. So we're looking at the next one, and that's 6-inch, which will do up to 7,500. Okay, looks like I made a mistake there. Yep, that was a mistake. All right, so change that 8 to I don't know, he came up with that. That looks like a 6. Okay, again, pay attention to the numbers in case you catch a problem that I made. created. All right, so that's going to be a 6. All right, so change that number on that handout that I sent to you. All right, so 1/4 inch to the foot. We'll do will be 6 inch. Okay. I think I might have been looking at the column there. In any case, doesn't matter. All right, moving on. A triangular roof, another weird shaped roof that we're never gonna see, except for a test. So what do we have? Okay, again, these are the same formulas, same kind of problems, just different numbers from the book handout that you have. Now I gave you this sheet, the actual answer sheet that I'm using right now. Let's see what it looks like. So we have another roof. This one's going to be 85 by 72. All right. So what that means is, let me draw this one out. Something like that. Okay, so this will be 85, like this. And this right here is going to be 72. Okay? That's how we find the area of the triangle divided by 2. All right, so let's look at the problem. Area equals the base times the height. This is the base times the height. Also, some of you might have learned it as the altitude, same thing. And divided by 2. So we take this number here, which if you multiply those two out, I came up with 6120, right? So this would be the area equals length times height, all right? And this equals 6,120. It's divided by 2, and we divide this by 2. Square feet. Okay. It looks about right. Okay, now the next question I'd like you to look for is, what is the roof drain size if this is one down? Now, I didn't mention that, but on number 1 and number 2, there's nothing about how many drains you have. So just go with 1. All right, so on this one here, which is actually number 8, we got a roof drain, which is the vertical, coming off this triangle. And the size of the roof is 3,060. So 3,060 looks like 4-inch pipe. 3-inch pipe only goes up to 2,200, and 4-inch pipe goes up to 4,600. All right, this falls actually right kind of in between. So this is going to be 4-inch pipe, which is marked there for you. So number 8, the roof drain size is 4-inch. Now the storm drain. All right, so this roof, once it drains down, this is 4-inch pipe. And let's take a look. Let's look on the chart on the 1/4 inch, 3,060. All right, so 4 inches is too small. 4-inch only goes up to 2,650. So we got to go with 5-inch. All right, so this is 4-inch coming down and 5-inch going across like that. Okay, so the answer there is storm drain, 1/4 inch per foot, 5-inch pipe. Okay, now again, normally I wouldn't have done this whole sheet like this here. We just go over the answers, but I this stuff is so important, and I know so many times over the many years that I was teaching, I'd get an update on some tests that have been state tests, and I do remember many times people saying, "Beware of the roof drains," or "Watch out for roof drains." There's a lot of them. Well, maybe gas pipe sizing, but this was kind of the sleeper. All right, so my advice to you is hang on to this stuff here. All right, put it aside. Of all the stuff I do this year, this is the one you probably want to save. because normally you guys aren't going to be designing roof drains until you go for your license. So put this away afterward. All right, that's it. That's number 8. All right, now the next one is a rectangular roof. Now this was probably well, I hate to use the word tricky, but this was the most difficult of all the questions that we had. And what I want to do is now you do have the sketch right there in front of you. In fact, I think the sketch will be better than anything I could do on the board. It does take a long time to use a straight edge on that whiteboard. Okay, so let's take a look. We got a rectangular roof. The size of this roof is kind of like a mill in Fall River. It's a big roof, big building. It's over half an acre. An acre, by the way, is about 43,000 some square feet. This is 24,000 square feet. So what we did is area equals length times width. Area equals 182 times 133 equals 24,206. Again, check my math. If anybody comes up with a different answer, let me know. Like I said, I already caught one mistake at the beginning. So there's the roof. Now there's 4 roof drains. Now this is more like it. Normally you don't have one roof drain unless it's a relatively small roof. And we install what's off the prints, right? There's really not too much on our part to be creative about how we're going to do it. It's just physically putting it in. But in this case, we're going to be designers here and set this up. So we got 4 roof drains. Now what I did is to set it up so that you can see that when you take the area, that 24,000, you divide it by 4, obviously. So each drain picks up 1/4 of the load. And 24,000, very easy math. It's roughly 6,000 and change per drain. So what I did is take a look at this. Each of these vertical drains, roof drains, is 6,051 square feet. Would be the design. That's how it would be done. You don't want any drain like taking a lot more water than any other one. So ideally, this is how the load of the roof would come down each of these pipes. It'd be an equal amount of water down each pipe. It runs into the horizontal drain. Now this is where it differs from the rest of this whole problem. The rest of the problem being 1 to 8. What they're looking for, or what I'm looking for, is the same question that was asked on the book question for number 9. What's the drain size between number 3 and number 4 roof drain? So what I did, right above the footage, the 6,051, I have the roof drains numbered, starting from the right, going to the left. 1, 2, 3, and 4. There's an arrow you'll see pointing at the 10. That arrow is where they're asking. So what is the drain size between those last 2 downspouts? Or last 2 roof drains, excuse me. So what you have to do is add up the 3 roof drains before it. So let's see what we got. If you take 6,051, what I did is, if you drop down the last part of this question, just below where it says drain size, you'll see I wrote them out. I didn't even multiply it. I just added them together so you could see it. And you'll see we got 6,051 3 times. It comes up to 18,154 at a 1/4 inch pitch. Okay, now let's go into the chart. So we go over to the horizontal chart because it's got 1/4 inch pitch, so we know it's horizontal. And we go down to the first one, again, very much like gas. The first one that can handle 18,154. So it could be actually 18,154 would be okay. But of course it's not. That is not exactly that number. So 16,000 is too small. That would have been 8. So we got to jump all the way up to 10. Okay, so we got a 10-inch pipe picking up the first 3 drains. Okay? So now what I also did is, if you look at going across, starting at the first one, number 1 and number 2, between them, I got the size going between them. So in other words, if you come down with a single 6,051 square foot roof, and you come down with, what was that, 5-inch. Okay, let me take a peek at that. I believe it's 5-inch. All right, so 6,051 on the vertical is 5-inch, correct? Okay, so you can put that there if you want. So right there where it's got 6,051, for each one of those, you could put 5-inch because they're all the same. The one's dropping down. Okay, so number 1, 2, 3, and 4, all 5-inch going down. All right, when it gets down to the horizontal line, that first one, okay, it was 5-inch like all of them. You can add that into your sketch. Then it hangs to the left and goes horizontally. Okay, let's go to the horizontal part of the chart. Horizontal chart says if it's 6,051, it's going to be 6-inch pipe. All right, and because it can't, 4,700 too small for 5-inch, got to go to 6. Okay, so that's the 6-inch you see at the bottom on the horizontal line. I put a 6. All right, then you pick up the second one. Right now, I know I didn't ask this on the question, but here it is. I did the whole thing out. So then, where the 6-inch coming across meets up with the next vertical down storm drain, you got the two of them together. So what does that up to? That looks like 12,103. Okay, so 12,103 looks like 6 inches too small. Only goes to 7,000. Got to be 8-inch. So between number 2 and number 3, we got 8-inch. So it goes 6-inch on the first one, then it bumps up to 8. Then the next one is 10. That was the question. That was the question between number 3 and number 4. Okay, same question that they asked on the first example we did the other night. Okay, so that's 10-inch. Now the only one that's a bit sneaky is the last one. Now the last one we had to add up all 4, and so instead of 18,000 for between the 3 and the 4, now it's up to 24,000 because we threw in another 6,000 square feet. So we go back to the original number. The whole roof, all 4 are roof drains, going horizontally would be 24,206. So let's read down the 1/4-inch chart. 8-inch isn't going to make it, but 10-inch does. All right, 10-inch actually will handle an extra 6,000 on top of the one we just did. If you notice, the one between 3 and 4 was towards the bottom end of the capacity of a 10-inch pipe. Okay, if you add 6,000 onto it, now it's up to what? 24,000. It's not at the end of the capacity, but it's getting up there. So 10-inch will also handle all 4 together. So as you look at this paper, the pipe sizes from the biggest to the smallest go 10, 10, 8, and 6. 6 being the smallest. Okay? This one is a very big deal. This is the kind of stuff you see on the exam. Got to know how to do it for the exam. Now, you'll also, and I know I've mentioned it several times, it reminds me very much of doing the gas chart. The gas chart, you really do. You guys that have been out in the trade for a while know that, right? If you're far enough advanced in your work, especially residential, you actually will be using that gas chart, sizing up gas pipe all the time. And it's kind of like this. It goes from the largest over, in this case, to the left of the, where it leaves the building, goes underground, would be like the gas service. And it gets smaller as you go to the very first drain. Again, just like appliances, smallest being at the very beginning. Okay, that's it. Like I said, that was the most difficult of all the questions on these pages, and the one I absolutely want you to hang on to this. All right, the last one is kind of an easy one. I just changed the numbers. So let's take a 35-inch gasket. I don't know, that'd be like a 3-foot pipe. I guess they're commercial pipes that big. I've heard of them. Never worked on one myself. But let's say you have to make a gasket 35 inches uh, with an 18-inch hole in it. The question here is, how many square inches? It's clearly just a math problem. So what you would do is, I set it up just like they did in the original problem. You'll see on the left side, I gave you the formula and substituted the numbers that are here. So it's diameter squared times 7854, 35 squared times 7854. Then we multiplied it, 1225 times 7854. And if you multiply 12 and a quarter times 0.7854, it comes out to 962. Now you can kind of do that in your head, like if you really screwed up and messed up on the decimal. This is like, 78% is pretty close to 3/4, which 9 is compared to 12. So that looks good. Now the smaller part of it, the smaller hole in the middle, would be an 18-inch hole. And it's the same problem, different number. 18 square times 0.7854 equals 324 times 0.7854. And then the area would equal 254. So what you would do is, again, just like the other one, you would deduct the center, the hole in the middle, the donut hole, from the whole thing, the whole circle. So it'd be 962.1 minus 254.4, and we're looking at 707.7 square inches. Okay. That doesn't look big enough. Okay, you know what? I'm going to double check the math on that. So let's just hold on that one for the minute. I can't really do it right this minute. And what I want to do is to the next video is a chapter in the book. It's chapter 24, and it's got roof drains in it, and not so much roof drains, but more storm drains. Driveway, which would be the same, by the way, as this roof drain. We use the same chart. And they're talking about perimeter drains that go around the new house. And some of you guys that have been doing new houses could enlighten me if there's been any changes in that business. I don't think so. I think it's probably the same as when I was doing it. But they mentioned using, like installing sump pumps. Now, sump pumps, storm drains, none of that requires a license. Any of you guys can do this stuff. All right. And I know I've done a few of these. Oh, I don't want to get into that whole lesson, but my advice is stay clear of 1/8-inch pitch. 1/8 inch is very, very flat. It's legal, and they mention it, and you can use any size pipe. Unlike plumbing, you got to start at 4-inch. 4-inch and up is, not start. That's the only size you can use, 1/8 inch, no smaller. But on storm drains, they let you go down to whatever. I'm looking at what is that, 3-inch? But 1/8 inch, remember, is only 1 inch per 8 feet. That's almost flat. And I don't know if any of you guys have seen sump pump drains coming out of house like 1.25 inches. It's usually 1.25 inches off those pedestal type sump pumps. They freeze solid in the winter. So unless you got some pitch on there, I can definitely see those things freezing up. Now, I don't know if that's because some slush froze up in there. It was a pitch problem, but they definitely freeze up in the wintertime. And if you got a water problem, you got a frozen drain. I don't know if it would blow the pump or what, but you obviously, at best, you could have a flooded basement. All right, so anyway, I wish I could ask you if you have any questions on these roof drains, because I don't think we're going to be doing any more of them, not this season anyway. And that gasket, what I'll do is double check the math on that gasket. I could do, I'm going to introduce that next lesson, go right into it, because some of it is a carryover from these roof drains. And when I cut this video off, I'll double check the math on that gasket. I got my question myself. The roofs, though, I think are okay. Now, if anybody here is pretty good at math, you want to check my math, please do. The last thing I want to do is put out nonsense, stuff that's wrong. Okay, So what I'd like you to do now is to take out the sheet on chapter 24. Okay, and I know you don't have the code. This is the textbook, but it's page 419 to page 427. I guess the pages are all marked on those page numbers are marked on those pages. So let's go to the first one, and let's talk about that. Okay. Now I know I've told you guys more than once that this book is not from Massachusetts. It's not. It's from Ohio. I don't know why I thought it was Chicago. But the guy that wrote this is, I think, he's a professor at some industrial college, and but he's from Ohio. So I'm guessing that the stuff that gets into the code area is probably from there. In any case, it's definitely not Massachusetts. I think we've already seen that with some of the things that we've discussed, where it's strictly plumbing. Some of the code wasn't quite up to our code, and I think I've told you this. The Mass code. They got a national code that some states adopt. I guess it's out of probably a financial matter and a reason. They don't want to pay for a financial. I mean, pay the money to develop their own code. Mass does. I don't know if they use something as a guideline, but it seems like they use their own code, the Mass code, when they write a new one. You find a lot of it is identical. The pages don't line up. That's the problem. And some of these, in fact, there was a couple of these test questions I had for you guys were several years old. So they date back to the last code book, which I think was the red one. So if any of you guys have the red code book in your truck, or the blue one is ancient, lose those. There's gray ones even before those. They were even smaller format. If you've got any color but green, you ought to get, and you're using the green yourself for school. I hope you are. But if your boss has like a red copy in his truck, you really should get a green one. I'll tell your boss to get it, because the code is close, but the pages are off by like 20. And there's a reason for that. Okay, they've obviously added stuff because the pages, I believe, are like roughly 20 pages different. Okay, so just a thought. You can mention that to your boss. Okay, so let's take a look at. I got to shift gears myself because I don't have that book right in front of my nose here. So let me get that out. Okay, so this is going to be on page 419, page 427. So this will be the first page of that group of pages that you were sent. I had a little trouble with this computer today too. I think it's not charging too well. All right. So let's take a look on page 419. Okay, this was going to be the beginning of the next lesson, but let's start it right now, and I'll come back to that flange. Okay, what this is called is stormwater and sumps. And at the end of the chapter, there's some questions. They're not hard. You guys can look them up. All right, so let's cover the lesson, and you guys can eventually look up the answers. It's not a hard chapter at all. All right, things they talk about here. I want to talk about myself. One of them is a combined system. Now, I know I mentioned this again because I was trying to do two classes at once. I'm not sure if I covered this with tier 1 and 2 or just 2, but certainly a review wouldn't hurt. In Fall River, right, we have what they call a combined system. What it means is this city is so old that they didn't have any things like sewage treatment plants when the city's plumbing system was set up in the 1800s, late 1800s. All right, the sewage treatment plant didn't come out until well into the 1900s. I always thought it was like the 50s, and somebody said no, it's even later than that. In any case, the system had no storm and sanitary drain separation. Newer cities that have the treatment plants uh, have both, right? So they would like parallel each other, I guess, going out of the house and into the street, and they join separate pipes. One of them would go directly down to the water, wherever the water was, a river or the ocean or whatever. And because it's just runoff groundwater, not a big deal. It can go right into the bay or the river. Uh, and the sanitary drain would go to the sewage treatment plant. Okay, an old city like Fall River, the systems join up. A lot of times you'll find, and some of you guys have already seen this, I'm sure, if you're working in Fall River, especially the old tenement houses, the roof drains, right? The rain leaders, excuse me, come down and they go from like metal. The old ones are actually round, the newer ones are rectangular shape. And then they would go into cast iron, maybe 5 or 6 feet high. And the reason for that is so they don't get whacked around with people walking alongside of it. And then they would cut into the basement. Many times it would go right back into the basement and join up with the building drain. Sometimes I believe there was a trap sometimes there. Now, is that plumbing? No, none of that is. Since when do you need a plumbing license to do gutters? This is all part, according to the book. I never really thought about it. It's part of the stormwater system, starting with the gutters, the downspouts, right, and any other piping to get it out to the street. Okay? In this case, it goes down and into the house. Now, even 100, 130 years ago, I guess they didn't want all the roof water flooding the place, so they put it into the sewer. And apparently it was big enough to handle it. Now, when you have no sewage treatment plant, who cares? So it rips out into the bay. Not a big deal in those days. Um, in fact, and I've seen photographs of the Quequechan River, right, like where it crosses Plymouth Avenue. It used to cross under Plymouth Avenue. I remember that when I was a kid, back around 1960, 62, somewhere in there, before they built the highway, just before the highway was started. And the river used to actually go under there. It was kind of swampy there. But before my time, I've seen pictures of it. They had houses and other buildings where the sewage was like dropped right out of the building into the water there and down into the bay. And there was one picture with some kids swimming within a few hundred feet of this outlet. Kind of, of where this sewage came out. There was a notation in the book that explained how things worked in those days. Nobody really cared. Went into the bay and just disappeared into thin air, which of course it didn't. Um, Now, many years later, all that's been filled in, and the river runs underground now, all the way from up at Watuppa Pond, all the way down to almost to Battleship Cove. It's only visible in a few places, but that's a combined system. Getting off the subject here, that's what they call a combined system, right? The stormwater and the drain water, the sanitary water, they cannot separate them without tearing the whole city up, and that's not going to happen. So they don't. So what happens now is the whole system dumps into the sewage treatment plant. Now, again, I know I told at least one class this, but I don't think I told both of you. So let's go through it one more time. The sewage treatment plant is down at the down there, almost down to the state line on Bay Street. Sewage comes in from the city. According to a guy that worked there, I asked about how much do they get. They have 15, 20 million gallons a day, typical day, and which is roughly what they used to pump out of Watuppa Pond. They used to publish the numbers. I don't know why they don't. And I said, that's like how much they take out of the pond. How come there's so much coming into the treatment plant without rain? And he says, there's so many leaks, springs, and things underground that it builds that number up. So when it gets into the treatment plant, without getting into all the treatment business, that takes a while talking about it. It's got a primary where all the water goes in and settles out, and then all of the sewage is pumped out, and the solids all settle to the bottom. Then it goes to another tank. It goes through the same process again, and then it gets pumped out into the bay through like a maze, and they disinfect it with a lot of disinfectant. And it used to be 87% cleaned up, which is still 13%, but a lot better than it was many years ago. And That's what goes into the bay. So that's a combined system, and there's really not much you can do about it. Now, most of what I just talked about is not plumbing, right? The stormwater part of it is definitely not plumbing. Don't need a license for any of that stuff. Where you do need a license is this. Let's say you have, and this happened when I was an apprentice many years ago. There was a house up in the Highlands that was moved way up towards Tansy School, I think it was. There was a house that was moved from one part of the lot to another, if I remember right. Been a long time, but the house was definitely moved. And when the house was reconnected, the house was old enough to have a system where I guess the downspouts all joined in at right inside the house or right outside the house. Neither of which is legal now. So this one you can make a note on. This is for your license, our license. If you have a stormwater drain coming down and it goes into the building like in the city, no problem. It's existing. Kind of like a three-handled tub valve. As long as it's existing, you're okay. But once you move the house from one location to another, I guess it's kind of like taking a bathtub out, trying to reinstall it with one of those old-fashioned below the tub rim level on the old tub on legs. Because I know what happened. My father had to bring those drains 10 feet outside the wall. At the time, I don't think I was that far along in the plumbing code. I was a pretty new apprentice, probably early 70s. And I know now what we were doing. We tied the stormwater drain that used to be tied in over near the house or in the house. I don't remember because the house was already moved by the time we got there. And we had to tie them together. So in other words, just picture this. The building drain goes out 10 feet outside the building where it becomes the building sewer. That's where we cut in a Y, right, to keep it legal. So the stormwater drained into the building drain or building sewer 10 feet out. Okay? That's code. All right. You got any problem with something like an unusual? I've only seen one time a house like that. You obviously check with the inspector. That's why it's always good to be on good terms with the inspector so you can call them for an unusual question like that. Most guys are pretty good. They get to know you. You're straight with them. You're honest. They'll help you out or they'll give you good advice. Okay, so that was a combined system versus a storm and a sanitary separate system. And you join them up. I made a few notes here to make sure I told you guys 10 feet outside the building. All right, stormwater. Now, stormwater would normally go to, in around this area, will go into the sewer and out to the sewage treatment plant. I think the book mentioned somewhere in there about a dry well. You guess you could, but that reminds me of stormwater, though. Just think of it. That's a lot of water to go into a dry well. Dry wells are usually small, and the dry wells that I've dealt with were usually for like a clothes washer. Now, there was a time when they were legal back in I think it was just when I went business in the 70s. There used to be a 2-inch pipe. Some of you guys might have seen it. There's a 4-inch pipe out the wall, as always, and a 2-inch pipe. You wonder what's up with the 2-inch? The 2-inch 45 years ago, went to a dry well. Now, again, I know we mentioned it, but let's cover that one more time. The dry well was where the clothes washer would go. Oh, the old, I don't know about the new ones, but the old clothes washers, I believe they had 2 cycles of water, quite a bit of water for every time you ran the washing machine. And it would pump out into a dry well. Now, it's what they call gray water. So what's gray water? Gray water is any like used water except from a toilet. So a sink, a tub, a shower, clothes washer, um, laundry sink, all right? Anything like that would be gray water. All right, and there was a time where we actually ran that out the building. I don't remember that lasting long. I just did it. It's been so many years. I think I did it a few times before that all changed. All right, so that would be where you had a septic tank. I guess they didn't want all that water in the tank. And the other thing too, those of you doing septic tanks, hooking to a septic tank, if you got a food waste grinder, garbage disposal, remember, I remember hearing about the design of it. there's two different designs, one with the disposer, one without. The one with the disposer is a bigger system to allow for the extra organic matter coming into it that has to be broken down and go out into the actually settle out in the tank, right? And the water going out into the leaching field. So I do remember hearing that. Now, again, that's not anything that we really have to worry about. That's a design issue, not plumbing. But keep an eye on that. If you can avoid putting, if you ever have your own, those of you who do, maybe it's not, shouldn't say you ever have your own house. Some of you already have your own house, I'm sure. But for those of you who someday have your own house, you don't have it now, remember that. Don't be too anxious to put a garbage disposal in. My advice. Okay. Let's see. I think that I'm going to have to switch over. Oh, yeah. I really want to long on this one. Okay. I'm going to switch over to another one and double check that